Hi guys, I'm Pat Kelly. Okay, in this problem, the directions say to use a graphing utility to approximate the relative max and the relative min of the function that they give us. Okay, so grab a graphing utility, and I'm a step ahead of you. If you grab your graphing utility, what you'll want to start with is to actually graph that function, which I try to do over here. So that's the step ahead that I am. But if you catch up to me, you might even see why I've drawn this ahead of time. Depending on what your settings are at, you might punch this function into your graphing utility and graph and not see everything. So I actually zoomed out a little bit. You're welcome to do the same. Because what I'd like to see to start with is just visually, where are the high points or where are the low points? Those are the relative max and the relative min that we're looking for, right? So let's start with what I'm definitely anticipating being a relative max, because that definitely looks like a high point for me. And again, depending on your settings, you might be off the screen. So let's get a good look at it. If you want to use the same window settings that I'm going to use, for my x min, I'm going to just do a -5, x max +5. For my y min, I'll start at 10, and for my y max, go up to 20. And if you were to graph that on your utility, you'll see a better zoom in, a better window on just that high point, okay? All right, now let's do what the problem asks us to do. We're now supposed to use our graphing utility to approximate that max. One of two ways you might be doing this, depending on what your graphing utility is capable of. The first way is to use some kind of zoom and trace features of your utility. So I'll try that here. If I choose zoom, what I want to do is zoom in and move my cursor around. You should be able to do something comparable so that you're somewhere near that high point. Enter that. And you can zoom in as many times as you want. And when you're ready, the second part of this first approach is trace. So now I'll choose trace. And the key here is you're tracing that curve, but you, the user, you're controlling where that cursor is. And the key is as you're moving the cursor around, what's the highest y value that you can see? Yours are going to differ from mine, so I won't even rattle mine off. But I'm bumping up and bumping down, and it looks to me, as much as I move around from left to right, the best I'm getting as a y value is 15. Okay, you should probably find something pretty darn close, maybe dead on. So that's suggesting to me with the zoom and trace approach that my max is 15. And also take note of what the corresponding x value is. For me, it's 0. So what I'm going to do is start an answer here of a relative max of, you probably want to report your answer as both the x and the y, 0, 15 for me. It's good. It's a good answer. But I also wanted to address the second approach. Depending on your graphing utility, you might be able to go right to a minimum or a maximum. Let's do the maximum in this case, if you have that feature. So for me, I'm actually going to go back to a standard zoom, which is where we started, and the graph might not look real good. You can't see everything, but you can immediately go to a calculus menu. If you have this, I have a maximum option. And yours should do something similar where it asks for the left bound. Let's just go to a -1. A right bound, I could go all the way to a 2 if I want, because the next thing it asks me is a guess, which I'm going to guess at 1. If you know it's 0, that's great. I'm just trying to show you your guess doesn't have to be perfect. I'll say 1. It'll think for a little bit. And my graphing utility is actually giving me a value of, be careful, mine's scientific notation. It says 2.2768, and then you might see that E for exponential, and mine says -6. I say be careful, because that is not saying that your x value is 2.2, right? The scientific notation actually means 5 zeros before that 2.50022768. But that's your calculator doing its best approximation of 0. Okay, relative min. Back to this overview that I have. We're talking about this low point, okay? which again, I might not be able to see depending on my settings. So if you want to follow me again, for my window this time, I'm going to keep, well, I'll change x min to even 0 is fine. And x max, I can go up to 5, it's fine. But for the for the y min, I'm going to go all the way down to a -20. And for a y max, -10. And if you graph that, I think you'll get a pretty good view of that low point, okay? And I'm doing that, getting that pretty good view, because I'd like to try that zoom and trace approach again. Okay, so I'll do a zoom maybe, I'll zoom in, move my cursor over, somewhat near that low point, enter. Zoom in as many times as you want. I think I'm ready to do a trace. If I do trace, again, what I'm doing is I'm bouncing back and forth. You're moving that cursor left and right, but you're focusing on the y values. How low of a value can I get? And I'm seeing like a -16.999. I think I saw at least 3 nines there. So I feel pretty good about even just calling that -17. Let's get an answer going of a relative min of, don't forget you need that x value as well. So when my y value is pretty darn close to a -17, looks like my x value is pretty darn close to a 4. And please don't lose sleep over the extra decimals you might see on your graphing utility. Remember, the direction said to approximate, okay? So this is pretty good. And you can do the second one with that second approach if you'd like. If your graphing utility has that minimum feature, which of course it would if it had the maximum feature. Use your lower bound, upper bound, take a guess, and you should actually confirm these values, okay? All right, thanks, and I hope that helped.